All right, here's a video key for test 4A. This is spring of 2023. History, but you don't get any blue on those. Here's the scores. Top 20. This is not blue, but good idea to work these again using green equation, launch equation, this time where you don't know time. This one is blue. Main mistake students made was, the main mistake they made was not writing down equilibrant. They got the resultant right, but that messed up their direction of the quadrant. And remember, it's catty corner quadrant. So a lot of people were, not a lot, but a few people put south of west. It's really north of east. You need to balance out these two forces, what you're trying to do. I'll leave this in here. This is not blue, but basically power rule. And I think I have 3 of you that still don't get the power rule. And you're going to have to learn that power rule because it's going to keep coming back from now until May. So learn the power rule. I'll just come in at lunch. We can 2 or 3 minutes. I'll get your work squared away on it. This one really isn't power rule. You could use power rule. You could just do the power rule every time, and then all these will pop out of it. Because eventually you get down to, what is A naught, what is V naught. But easiest way is just to know the coefficient. Sorry, late Monday night. Know the coefficients that go with the pink equations. Know the coefficients that go with the purple equations. Or look off the sheet on the, on the reference sheets you had. This one is blue. Came down to, although I think you all did pretty well on it, but there was enough points taken off that I think blue will help a lot of people. Main mistakes people made was they got the directions wrong on their arrows. They didn't really, there's a few students that didn't, they copied them, but they just kind of haphazardly put the angle on there. It has to be like buoyancy, BA, has to be exactly what it looks like here, transferred over here. I put MG on there so you kind of had an anchor so you didn't go off the page. Then the order you added them up didn't matter. And remember that the summation of forces is the resultants. It goes from the very beginning to the very end. Your arrow had to be correct there. Number 7 is blue. Main mistakes here, once again, power rule. Most people got the power rule right here. It's just that, here's the main mistake on this one, was 7B. A lot of students, probably a dozen students, thought that I was asking for where the thing turns around, but it says the highest speed. What's the highest speed between direction changes? That is, by definition, point of inflection. And that's where acceleration is 0, okay? So, yeah, and then that kind of goes with the other 7B over here. Just notice the 2 7Bs. But that one is to to show where those point of inflections are. And so it happens at 1 second, and that relates to a relative minimum on the velocity versus time, which then relates to a point of inflection on the position versus time, and that's a 0 point on acceleration versus time. This one turned out not to be blue, which. I can only go 90 points out of 150 to make 90 points blue. And it came down to this one and number 6. And second hour picked this one, barely. They picked number 6. So this is not blue, but it's still a good idea to go back and look it over because simple harmonic motion will come back at some point, either it's packet 5 or packet 6. 6 points for the envelope, 6 points for simple harmonic motion. He says 6 oscillations. Okay. From there, you can find out what will be the omega. Omega is 2 pi over the period, so 2 pi over 3 is omega. The amplitude is not 6, that's the maximum amplitude, but the amplitude changes with time. 9, originally had 9 as black, but really, and I don't even know if it deserved to be black, because a lot of people got a lot of partial credit on it. But the reason why I switched it to blue plus, which means you can get about 75% back on it, is because yes, it is the hardest problem on the test, in my opinion. It does involve the chain rule, but there was an example problem very similar to it in the reference sheets that you had on you had a PDFs of them. You go, well, I didn't know to look there. That's because you didn't look over the reference sheets. That's the playbook for the test. You need to look over the playbook before you walk into the test. So for test 4B, you're going to have, I don't know, 55 pages or so instead of 48. So be looking over, especially the new stuff, but also old things like, where do I find quadratic formula? Where do I find the flow chart for projectile motion? Where do I find the blue quad? All these little things that you need to be able to, that should be that's the playbook for the whole class. So look it over. Anyway, if you'd seen that, you would have gotten through these first couple of steps pretty easily, and you still would have had to do all this. Anyway, so it's a blue plus. Okay, and this one's blue. It's so you can get up to 9 points back if you left it blank. Some did leave it blank. Most people gave it a shot. Got something on there. Main mistakes, you had to realize it's 2 oscillations. The way I knew that was it was 16 seconds, and then the period is 2 pi over omega, which gave me 8 seconds for a period. So one, and I know it's cosine. It says a cosine oscillator. Some of you went for negative cosine, but that's okay. I didn't say it wasn't negative. Negative cosine and cosine, if it's a pendulum or whatever it is, they're fine either way. It's just your perspective on where you're saying your reference point is all that changes. As long as you stay consistent all the way through, all the way down. So this is called a black. It's not a black problem. It's a black trio. So you're just taking derivative, right? But when you do that, you have to bring out because it's chain rule, you have to bring out the omega out front each time. And so when you do that, that changes the amplitude. That changes this is position versus time. This is velocity versus time. This is acceleration versus time. And if you look back on some of the reference sheets, I try and go in detail as to why that is. Why is this 15.7? I changed to centimeters per second. Why is that 20 meters? That's 15.7. Why is that 12.3? We noticed that the amplitudes were going really high. And that is true. If omega is greater than 1, the amplitude gets multiplied. But our omega was 0.25 times pi. So whatever that is, 3.14 divided by 4, about 0.75 or so. So our amplitude will drop off each time you bring another pi in. See, and there's a reason, because that's a slow oscillation. Look, it took it 16 seconds to go back and forth twice. So 8 seconds to go one oscillation. That is a very slow, if it's a pendulum, it's a very, very long string. Okay, like, I don't know, 10 meters or something. So it's really slow going back and forth, which means that it doesn't need that high amounts of acceleration to turn it around, and the velocity never gets to a super high amount, as it goes through equilibrium. It's actually pretty slow, 15 centimeters a second. Okay, so an interesting question.